Hello students, welcome back again. In this video we are discussing an example based on Newton-Rapson method to find the root of an equation x cube minus 2x minus 5 equal to 0. Okay, in the previous class we have discussed the same example by using regular falsi method or method of false position. Okay, you can if you still have not watched the same example by using the regular falsi method, you can go and watch it. So now, as usual, students, we people already aware that first we are writing the formula. Okay, what is the formula of Newton-Rapson method? Okay, so we have general formula is, you people already aware that x n plus 1 is equal to that is x0 minus this is xn minus f of xn divided by f dash of xn. So we are applying this formula iteration wise. In the first iteration, if you want to use first iteration, substitute n equal to 0, you will get x1 is equal to x0 minus f of x0 minus f dash of x0. Okay, so second one, we are finding the interval. You people already aware that how to find out the interval. Here we have f of x, the left side value, which is x cube minus 2x minus 5 is equal to 0. So we are not writing is equal to 0. As usual, we know that we are going on substituting the value of x is equal to 0, right? First we substitute x equal to 0, f of 0 is, you will get minus 5. Okay, and substitute x equal to 1, you will get f of 1 is equal to 1 cube minus 2 into 1, minus 2 minus 5, you will get minus 6. Substitute x equal to 2, you will get f of 2 is 2 cube is 8, minus 2 into 2, 4, 8 minus 4 minus 5, you will get minus 1. Remember, these are all negatives, less than 0, less than 0. By substitution of x equal to 3, you will get f of 3 is equal to 3 cube, 27 minus 6 minus 5. Okay, so you will get approximately 16, which is greater than 0. As you know that in the previous class, the root lies between. Therefore, the root lies between. First, we are writing the value of x. By substituting in the given equation, you will get negative value, that is 2, and then we write the value of x, which will take positive. So root lies between 2 and 3. As you know, then we are drawing the number line. By substitution of 2, you will get minus 1 in the left side. By substitution of 3, you will get 16. In the Newton-Rapson method, what we are going to do is, first we have to have initial approximation. We need initial approximation or initial root. Initial approximation or we need initial root. So what is the initial root we are going to consider? Here we have two options. We have 2 and we have 3. And we have to observe, by substitution of x equal to 2, you will get minus 1, which is very close to origin, close to 0. By substitution of 3, you will get 16, which is far away from 0. So therefore, we are going to take the root which by substituting in the given function, which is very close to 0. Therefore, x0 is 2. That is, initial root is 2. Why 2? Again I will tell you. By substituting x equal to 2, which is you will get minus 1, which is very close to 0. Okay, since 16 is far away, by substitution of 3. So x0 is 2 is the initial root. Then we will go for first approximation. Before going to first approximation, we have f of x. F of x value is x cube minus 2x minus 5. Okay, 2x minus 5. We also find out f dash of x. F dash of x is necessary. X cube differentiation is 3x square, 2x is 2. Okay, so let me go for first approximation. Okay, first iteration or approximation, you can call it as. In the first iteration, okay, first iteration, as I told you already, in the formula, that is in the Newton-Rapson method, we need to substitute. So what is the formula? We have xn plus 1. Xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Okay, here you substitute n is equal to 0. The first iteration is x1 is equal to x0 minus f of x0 divided by f dash of x0. Okay, fine. So x0 value you know already, x0 is equal to 2. You can substitute x1 is equal to 2 minus f of 2 divided by f dash of 2. Okay, this is 2 minus f of 2. F of 2 means you can write that is 2 cube, right? 2 cube is 8 minus 2 into 2, 4 minus 5. 8 minus 4 minus 5 is, will get minus 1 divided by f dash of 2. 3 into 2 square. 2 square is 4. 4 3s are 12. 12 minus 2, 10. So which is 2 plus 1 by 10. 1 by 10 is 0.1. 2 plus 0.1 is 2.1. 2.1 is the first iteration root. That is x1 is equal to 2.1. Okay. Now we'll go for second iteration. What is second iteration? We substitute n is equal to 1 here. You will get x2 is equal to, this is decreased by 1, minus f of x1 divided by f dash of x1. Okay, fine. Now which is, just substitute the value of x1. x1 is 2.1 minus f of 2.1 divided by f dash of 2.1, which is equal to 2.1 minus f of 2.1. I will write the equation. This is 2.1 whole cube, right? Minus 2 times of 2.1 minus 5. You know f of x value, right? Divided by f dash. F dash is 3x square. X value is 2.1. 3x square minus 2x differentiation is 2. Otherwise you can go back and observe f of x and f dash of x. F of x is x cube. X means 2.1 whole cube minus 2 into 2.1 minus 5. F dash is 3 into x. X is 2.1 whole square minus 2. Student, you can use the calculator to calculate this. This is 2.1 minus you evaluate this separately and evaluate this separately and divide these two, okay, and subtract from 2.1, okay, you will get 2.0942. okay, as I mentioned already, you calculate this separately and you calculate this separately and you divide this, and after dividing, whatever the value you will get, you will subtract from 2.1. okay, let's go for third iteration. We will go minimum 3 iterations here. Okay, third iteration. Okay, so here x2 value is 2.0942. okay, what is third iteration? x3 is equal to, substitute n is equal to 2 here, that is x2 minus f of x2 divided by f dash of x2. okay, fine. x2 value you know already, 2.0942 minus f of 2.0942 divided by f dash of 2.0942. okay, fine. Now which is equal to 2.0942. you know f of x value, I will write, that is x cube, 2.0942 whole cube, x cube minus 2 times of x, 0942 minus 5 is the f of x divided by f dash 3 times of 2.0942 whole square minus 2. As I told you in the previous in the second iteration, that you calculate this separately and this separately, then you can divide this separately, and whatever the value you get, you can subtract from 2.0942. here you will get 2.0946. this is x3, and if you want to correct for 3 decimal places, after decimal places you have 0.94, this is 6, you can also write 2.094095. okay, thank you so much for watching. okay, and another thing that if you want to improve further, again you can go for third iteration also, okay, for fourth iteration also. okay, thank you so much students for watching. We will meet in the next video. Thank you once again.